Hi, today let's do something crazy. We'll imagine eukaryotic cell organelles as part of a scrumptious meal, a ramen bowl. Let's start with our bowl, which today will represent the cell membrane. The cell membrane controls what's in our cell, just like most plates and bowls controls what's in our meal. If it's not inside of the cell membrane, it's not a part of the cell. Next, we have the cytoplasm. Think of the cytoplasm as cell soup, ramen broth. The cytoplasm is the fluid-filled space in which we suspend/hold our organelles. I had to change the color of the cytoplasm because I needed you to see what I was putting in the cell, but anyway. Where are we getting the bulk of our energy? From the actual ramen noodles, of course. So because the ramen noodles give us so much energy and provide most of the energy, we'll call it the mitochondria. As biochemists, we're going to refer to energy as synonymous with ATP when we're talking about cells. So the mitochondria generates ATP via cellular respiration and powers the cell. Now we'll add my personal favorite part of ramen bowls, the boiled egg. I love the boiled egg of ramen bowls. They are essential, and I'll explain why they're essential to your cells too. Let's imagine the egg white part of the egg as our nucleus and the yellow egg yolk as our nucleolus, okay? Like most eggs of all species, the egg white part of the nucleus is responsible for protecting our DNA and storing our DNA. Did you know that the egg yolk has more protein than egg whites? So, I hope it's then easy to draw the connection by understanding that the nucleolus produces ribosomes, and ribosomes are essential for protein synthesis, making proteins. Next, we have our ribosomes, which should be easy to associate with protein since I used pork to represent it. I love pork, guys. As I said earlier, ribosomes are essential for protein synthesis, and they make proteins by basically linking amino acids together, which we won't get into. Just know that they make proteins. Some people like to add mint to their ramen bowl, so let's use that. Most people understand that mint is what keeps things fresh, what cleans things up, at least in the mouth. But here in the cell, let's imagine mint as something called a lysosome. We're imagining mint as lysosomes because lysosomes break down waste, damage cell parts, and invading bacteria. I was really proud of myself for making this connection, so I hope it's really easy for you guys to understand. So far, our ramen bowl is looking really good, but what are we going to use to move things around? What are we going to use to maybe even detoxify? We're going to use a spoon and chopsticks, okay? So we're going to make the spoon analogous to something called the smooth endoplasmic reticulum, and chopsticks are the rough endoplasmic reticulum. I hope the pointiness of chopsticks and the smoothness of a spoon is what's going to help this analogy. The smooth endoplasmic reticulum does not have any ribosomes, which is why it's called the smooth one. It makes lipids and detoxifies harmful substances. Imagine this spoon as coated in charcoal. Some charcoal-infused utensils can actually detoxify food, just like the smooth endoplasmic reticulum can detoxify the cell and its substances. Spoons are also used to slurp up the oils and lipids. I hope that analogy allows you to associate the smooth endoplasmic reticulum with making lipids and detoxifying substances. I know most chopsticks are used for both ramen and the meat and the egg, but let's just imagine this chopstick is for the pork only, okay? So our chopstick, aka our rough ER, has ribosomes and it processes and transports proteins. Now in this famous ramen shop, we have our famous ramen purple sauce, okay? And we're gonna call this sauce the Golgi apparatus. This purple sauce is really good at modifying the way that the pork tastes, so it modifies our proteins and it modifies the way the fat tastes in the food, so it modifies our lipids. The Golgi apparatus modifies, sorts, and packages proteins and lipids. Here's a key component though. The Golgi apparatus actually in the cell puts proteins and lipids into something called a vesicle, which is basically a bubble that transports material throughout the cell. In this case, proteins and lipids. Just a fun fact, but not really analogous to a sauce. Still, it's important to remember that the Golgi apparatus uses vesicles to transport material throughout the cell. Finally, we're going to think of centrioles as a toothpick holder. This is because centrioles organize something called microtubules, which are basically long fibers. In fact, if you look up what microtubules look like, they'll look a lot like that picture of toothpicks. Anyway, centrioles are crucial for cell division, specifically because of their role in organizing microtubules. That is all. That is our entire ramen bowl analogy. Let's go through it from the top. The cell membrane is our ramen bowl. The cytoplasm is our ramen soup. The mitochondria is our ramen noodles. The nucleus is our egg whites. The nucleolus is our egg yolk. The ribosomes are our pork cutlets. The lysosomes is the mint that some people add on. I don't like it, but some people do. The smooth ER is our charcoal-infused spoon. The rough ER is our chopsticks. The Golgi apparatus is our special purple sauce. And the centrioles are our toothpick and toothpick holders. That's it. That's all. That's our ramen bowl analogy. Of course, no analogy is perfect, but I hope this helped you in some little way or a lot. Thank you so much for watching.